Hello everyone, this problem has been asked in GATE 2013 and it is of 1 mark. GATE 2013 and it has weightage of 1 mark. So let us see what the problem says. The problem says that which one of the following statements is not true for a continuous time causal and stable LTI system. And the options are all the poles of the system must lie on the left side of the j omega axis. Zeros of the system can lie anywhere in the spline. All the poles must lie within mod s is equal to 1. And the last option is that all the roots of the characteristic equation must be located on the left side of the j omega axis. So clearly this problem is from the signals and system subject. And if you want to have a detailed concept behind this problem, you can refer the NPTEL lecture, that is LTI systems, causality and stability, and the NPTEL course name is Signals and System by Professor Kushal Shah, Department of Electrical Engineering and Computer Science, IISCR Bhopal. The YouTube link is also given here. So let us solve the problem. So what are the conditions for causal and stable system? And these are the mentioned conditions. In a causal system, the ROC of the system transfer function should be in the right half plane, and that is to the right of the rightmost pole. And second thing is that in a stable LTI system, all the poles of system should be in the left half of S plane and no repeated pole on the imaginary axis. Now uh, from this important second point, we can see that in option C, there is mod s is equal to 1, that is having one pole in the right hand plane also. So it does not satisfy the stability criteria. So mod s is equal to 1, that means s is equal to plus minus 1. So we can say that s is equal to plus 1 lies on the right half of S plane. So it violates the condition for a stability of LTI system. So we can clearly say that option C is incorrect for continuous time causal and stable LTI system. So just be careful. We have to find the which of the following is not true for a continuous time causal and stable LTI system. And the last point is that for a stable system, all the roots of the characteristic equation must be located on the left side of j omega axis. Even if one root lies on the right side of the S-plane, the system becomes unstable. So let us see the options. So the first option is that all the poles of the system must lie on the left side of the j omega axis. So from the second point, we can say that all the poles of the system should be in the left half of S-plane and no repeated pole on the j omega axis or imaginary axis for a stable LTI system. So this is correct. And the second option is that zeros of the system can lie anywhere in this plane. Yes, it is true. There is nothing relation of zero with causal and a stable LTI system. So this is true also. And third option is that all the poles must lie within AC mod S is equal to 1. So this is going to be incorrect. From the second condition, we can say that in a stable LTI system, all the poles of the system should be lie in the left half of its plane and no repeated pole on the imaginary axis. But here we can see that mod s is equal to 1, that means s is equal to plus 1 lies on the right half of S plane. So this violates the stability condition for LTI system. So this is incorrect for continuous time causal and stable LTI system. And the last option is that all the roots of the characteristic equation must be located on the left half of the j omega axis. Yes, this is also true. From the last point, we can say that from for a stable system, all the roots of the characteristic equation must be located on the left side of the j omega axis. Even if one root lies on the right half of a plane, the system becomes unstable. So this is also true from the last point. So now let us see the conclusion. So conclusion that options A, B and D are satisfying property for a continuous time causal and stable system, while C is incorrect for a continuous time causal and a stable LTI system. Therefore, C is the correct answer. That's all. Thank you.